Hi, welcome to Networking Fundamental Concepts video series. I'm your host, Steve Baker, and today we will explore the key concept, network summarization. We'll first take a look at exactly what network summarization is all about, then the method that we use to actually calculate a summarized address, and finally a few real-world examples of how we can implement this into our network design. So without further ado, let's get started. So let's take a quick look at what network summarization actually is. Basically, it's taking a bunch of networks that all belong to a common classful identification and combining them into one ID by first finding a valid starting network and then manipulating the subnet mask of that starting network so that it includes all of our individual networks. Take a look at the animation below. Here we have 8 individual subnets, and by applying the summarization process, we can calculate a supernet encompasses all of the individual subnets. Think about how the Postal Service operates. Rather than ship parcels individually, they're first sorted by a common zip code, placed on a truck, and shipped to the next processing center. From here, final delivery can then occur based on individual addresses. With summarization, instead of a zip code, we're using a common subnet. We send all those packets that fall within that summarized range to the next hop router. Once at the next hop router, that router can then send the packet on to the actual subnet to which it belongs. Summarization is useful for many networking situations. One of the most common being route aggregation. This is when we decrease a router's routing table by substituting a single summarized route for hundreds or possibly even thousands of individual routes. You'll also see the process applied in other areas, such as access control lists, and potentially even eliminating unnecessary dynamic routing updates. There are many areas where summarization can improve network performance and efficiency. So now let's take a quick look at the process we use to calculate our supernet ID and its corresponding subnet mask. First, we need to find the lowest subnet in our range, and then we need to locate the highest subnet in our range. We can either rearrange them or just pick them out. Once we have those discovered, then we want to compare the lowest to the highest, and we need to convert those both into the binary representation. Now what we're doing is finding where the bits are in common across the two. So we determine which bits those are, and wherever those bits stop matching, then we want to draw ourselves a demarcation line there to indicate that those bits no longer match. Now we simply compare the bits and we bring down the same bit where they match in our individual subnets to begin forming our supernet ID. So here you can see that if it matches on that first bit between those two individual subnets, we just bring that same bit down to begin forming our supernet ID. And we do that all the way across the board. If it matches, we bring it down until we get to our demarcation line. Once we get to our demarcation line, everything to the right of that line becomes zeros. Once we have all of those bits determined for our supernet ID, now we can take it back to a decimal format. So we just convert that binary representation of the supernet back into a decimal format. And the next step in the process, we need to determine what is the subnet mask that's going to go along with that supernet. And we just simply count the number of matching bits that we had, and that becomes our subnet mask to go along with our new summarized supernet. To finish up this video, let's take a look at putting summarization actually into action. Let's say we have this simple network design here where we have our corporate network router attached to 2 branch office network routers. On branch 1, we've got the addresses 10.0.0.0/24 all the way through the subnet 10.0.127.024. That's 128 subnets. On branch 2, again, we have 10.0.128.0 through 10.0.255 for another 128 subnets. If we wanted to get a packet from this PC to one of those individual subnets, on XYZ Corporate's router we would need 256 individual routes. With summarization, we can reduce that to 2. So we could summarize the first range of addresses as a 10.0.0.0/17, and that would cover us on this third octet from 0 through 127. And then we could put a second summarized statement in for 10.0.128.0/17, and that would cover us from 128 through 255. This is known as route aggregation, and it reduces the overall memory requirements on the router as well as the processing requirements, and it increases the efficiency of the packet being forwarded because instead of having to go through 256 individual routes, now it's only compared against 2. This process can also be very effective when we're utilizing access control lists. Let's say that we wanted to allow this PC to reach these 2 networks, but deny it access to the rest. If we organize our ACL statements correctly, we could put a permanent statement to the 10.0.0.0 with a /23, which that means we've covered a range of 2. Starting at 0, that would be 0 and 1. And then we could follow it up with a deny to 10.0.0.0/17. So if a packet arrived and it was processed against this ACL, and if it was headed to, say, the 10.0.1.0 network, the permanent statement would allow it through. If it were headed to the 10.0.3. network, for example, the permit statement here would not apply, and it would process down to the deny statement, and then it would be caught in this range from the 0 through 127, and it would be denied. I hope you found this video helpful. If you haven't done so, please subscribe to my YouTube channel, and you'll be notified about future videos as they're released.